Hello everyone. In this video we are going to discuss about topic time domain representation of LTI systems. The title itself says we are going to discuss about the time domain representations, whereas LTI is nothing but L stands for linear, TI stands for time invariance. L stands for linear and TI stands for time invariant. Linear time invariant systems. Okay. Let us consider a basic input-output equation. If x of t is an input operated with an operator h, which leads to an output y of t, then for this case, for an input of x of t with an output y of t, which is operated by an operator h, time domain representation relates the output. Time domain representation relates the output y of t, the output y of t signal to the input signal, which relates the output signal to the input signal when both the signals are represented as a function of time. Remember, time domain representation is nothing but relating output signal to the input signal when these two signals are represented as a function of time. Only when these signals are represented as a function of time, we can relate the output signal to the input signal. Okay. As we all know, we have discussed the properties of the system in our previous videos. We all know linearity. We all know about linearity. Linearity is a property where it obeys the superposition theorem, right? Since we are talking about linear time invariant, which means the system is obeying a superposition theorem. Since LTI system exhibit superposition property, since the LTI system exhibits superposition property came because of linearity. Since we are talking about linear time invariant, superposition property also exhibits with these systems. Since LTI system exhibits superposition property, these systems are easy to analyze. Since it possesses the superposition property, it is easy to analyze this system, and we can represent the input to an represent the input to an LTI system in terms of linear combination of a set of basic signals. Since it possesses a superposition theorem, we can represent the input. The input of an LTI system can be represented in terms of linear combination of a set of basic signals. We can split the input signal into a set of basic signals and we can represent it. Okay, it's a linear combination. Okay, which in turn, when we split the input signal into set of basic signals and we can represent it in a linear combination format, which helps to find the output of the system in terms of the responses of these basic signals. Since we are representing the input signal in terms of set of basic signals, we can also, which in turn helps the output of the system in terms of responses to these basic signals. Okay, this is what makes it easy to analyze the LTI systems. Okay, to analyze this LTI system, we are having a different time domain representation of the LTI system. We are having different time domain representation of LTI system, and among them those are first one is in terms of impulse response. First one in terms of impulse response. Second one, difference bar differential equation. Difference bar differential equation. And lastly, block diagram representation. Three different time domain representation of LTI systems are in terms of impulse response, difference and differential equation, and lastly block diagram representation. Remember, in these three cases we are going to represent the input signal in terms of a set of basic signals. Okay, linear combination of set of basic signals, which in turn helps to analyze the output in terms of responses to these basic signals. Okay, this is about the introductory part of time domain representation of an LTI system. In the next video, we are going to discuss in detail about these time domain representation of an LTI system. In the next video, we are going to discuss about impulse response representation of an LTI system. Hope you people understand. If you have any doubts, please do message on my comment box. We'll be connected. Thank you.